All right, welcome to day 5. This warm-up should be put in your Friday box. So we've got page 47 for homework tonight. And today's topic, we're going to do arithmetic series. So we want to write a summation notation, just one for each of these. So we'll start with our summation. Pick some variable. Remember, n equals 1, or whatever variable equals 1. 1's the easiest to start with. So we have 1, 2, 3, 4, 5, 6, and 7. So 7 would go on top. Our pattern is linear in nature. It's going down by 2 each time. So we want to think of an mx plus b. So our m we would have is negative 2 because it's going down 2 each time. But if we sub in 1, we get back negative 2. And we want to get back 5. So we need to think about what do we need to increase negative 2 by to get to 5? Well, it's 2 to get to 0, and 5 extra, so that's 7 that we'd have to add on. In our next one, we'll again start with n equals 1. 1, 2, 3, 4, 5, 6 terms, so the 6 would go on top. Remember, if you're not starting with 1, it won't be the number of terms on top. You'll have to see where you would end up. This time our pattern is we're multiplying by 3 each time. So we want to think of something in an exponential form, and a times b to the x, or a times b to the n in this case. And we're multiplying, since we're multiplying by 3, we would have 3 to the n. Well, we need to figure out what that a is out front, because when we do 3 to the first, we want to get 4 back. Well, 3 to the first is just 3, so we'll divide that over, and our a that we would want would be 4/3. So 4/3 times 3 to the n. So your homework, again, I'll pause on each of them for a second. The summation ones that you had to do out, remember you had to show that you're subbing in and then go from there. Now, I wrote the simplified form for them, but like for example, for this one, you could have done, sorry, not that one. For like the first one here, instead of writing 1, I wrote what it simplified to. You could have done 2 times 1 minus 1 plus 2 times 2 minus 1 plus, and done that for your work shown. That would have been fine as well. And same thing for each of them. There's your next ones. So this was 2 steps. You had to write the summation first, and then you had to find what it equaled. And there's each of your options there. Again, you can pause and check your answers. Any ones you have questions on, you can post them to the content discussion board on the Schoology page. So we'll start today on page 22. The first few days of this unit, we looked at sequences, also sometimes called progressions. And a sequence is a list of numbers that has some type of pattern to it. Well, when you decide to then add up that list of numbers, it now becomes a series. So that's a key thing. When you see the word series, you need to know we are going to then add up all the terms. So we want to see if we can find the sum of the terms from 1 to 100. Notice we're really just adding 1 each time. And the thing to note here, if you combine 1 and 100, it gives you 101. If you combine 2 and 99, that also gives you 101. If you combine 3 and 98, that also gives you 101. If you combine 4 and 97, that also gives you 101. So notice it's always going to give you 101. So then we need to think about how many of those 101s would we have? Well, if there's 100 total and we're pairing them off, there should be half as many of the pairs, so 50. And if we multiplied this out, we should get 50 50, 5,050. And the idea behind that is where our formula comes from for that. So if we had in general our terms A1 plus A2 plus A3 and so on, that 101 you could think of we got it from adding the first and the last term. So in here would just be the first plus the last. And then out front was half the number of terms, because 100 was half of 50, so it's just n over 2. And that is our summation formula for an arithmetic series. So just a reminder, arithmetic means the individual terms are different by some common difference that's being added, or it might look like subtraction if it's a negative number being added over and over again. Our notation for the sum is that Sn there, and this box is on the bottom of page 22, by the way. Now in this unit, there are 4 formulas that you have to memorize. And we've seen 3 of them so far. So I'd actually like you to flip to the front of your packet. And on the front of your packet, I would like you to write the 3 formulas that we know so far. So the 3 we know so far is D. If you're not sure how to find the D value, you can do the second term minus the first term. If you're not sure how to find R, you can do the second term divided by the first term. And then our third one that you have to memorize is the one we just saw. Our arithmetic series formula. And that one was Sn is equal to n over 2 times A1 plus AN. And there's one more that we'll learn tomorrow, or next class, I should say, that we'll add to this list. So today we're going to practice on using that formula. So if we go to the top of page 23, we want to evaluate the first 20 terms, and we've got a series there. Remember, series is if the terms are all added up. So first question we should always ask in this unit is it arithmetic or geometric? So we want to look from term to term and see, are we adding or multiplying? Well, we appear to be adding by 3, so this is our arithmetic series formula, which is not surprising because that's what we're focusing on today, but on the test they'll all be mixed together, so it'll be a little bit more mysterious. So we want to find the sum of the first 20 terms. So our notation we would use is S20. That means n is 20, so we'll have 20 over 2. Our first term is 4. And then an, the last term, this is what makes this formula hard. We need to go to our reference sheet and take our arithmetic sequence formula and use that to find what goes in the an spot. Notice I put the d in parentheses. That's something we want to try and remember to do. So we're finding our 20th term. Our a1 is 4. We'll have 20 minus 1 times our d of 3. And if we punch that in the calculator, that'll give us 61 after we add the 4. So that comes over here, and that is what becomes your an. So what we've just seen is why doing arithmetic series can sometimes be the most challenging thing of this unit. We really had to use 2 formulas. The summation formula, the arithmetic series formula, which you have to have memorized. But then to find that an spot, we had to use the formula from our reference sheet to find that 61. Well, now we could just punch this all in the calculator, and it ends up giving us 650. So I believe in your packet, I might have it as something with square roots of 3. I want to change that if it is still that in there. And I would like you to cross it out and write this series instead. And we'll have the same directions. We'll do the first 27 terms. So cross out what's there on the bottom of page 23 and put this instead. So they tell us it's an arithmetic series. So we automatically know we're doing n over 2 times a1 plus an. we're doing the first 27 terms, so that's S27 equals 27 over 2 times our A1 is 2.7 plus, we don't know. We've got to go off to the side and from our reference sheet use our arithmetic sequence formula. Putting that D in parentheses, of course. A27 is what we're looking for. The first term was 2.7 plus, we'll have 27 minus 1. And then our D. Okay, if you're not sure of the D, some of you might be able to just look at it and see, but if you're not sure, you can always do the second divided by the, or minus the first. So this is 3.1 minus 2.7, which would give us 0.4 for the D. D is the common difference. It's what it's changing by each time. So if we punch that in the calculator, that'll give us 13.1, and that's what we bring up to be the AN. Now just punch that all in, and we get 213.3. So basically, we could have written out all 27 terms and then added those all up, but this formula allows us to find that more quickly. Now, if it's only like 5 terms you're adding up, it's probably going to be easier to just punch all 5 in the calculator and add them up. But say you have to add the next 500 terms, the next 1,000 terms, this just makes you much more versatile and be able to handle much larger lists. All right, so if we go to the next one, the top of page 24, they tell us it's a series, so we need to be asking ourselves arithmetic or geometric. Now, even if they didn't say series, the pluses would clue us into that. Well, we are going up by 7 each time, so that's arithmetic. So our formula we've been working with today, n over 2 times a1 plus an. Well, notice they don't tell us how many terms the series is. So that's the mystery we have in this case. We don't know the n. So we're going to have s. We got to figure out s what number. So we don't know what n is. It's n over 2. We know the first term is 2, and the last term, the an, is 135. So we've got to go to our arithmetic sequence formula again. In order to figure out what the value of n is. Well, 135 was our an. Our a1 was 2. We don't know n, and our d was 7. So we saw in a previous lesson there was 2 ways that we could approach this. We could distribute the 7, or we could not distribute it. I'm going to choose to not distribute it. So we got 133 equals n minus 1 times 7. Because then what you could do is you could divide both sides by 7. And that would end up giving us 19. When we punch it in the calculator, add your 1 over, and we get that n is equal to 20. So we can just fill that in over here, punch it in our calculator, and we get 1370. So a good rule of thumb is when you're doing an arithmetic series formula, if you find that you don't know something, go and do the arithmetic sequence formula that's on your reference sheet, and that should find it for you. So we're going to skip the next one. And we're going to go to the top of page 25. So we want to evaluate the series. So they give us the sequence. We want to do the series where we add them all up. Notice the pattern, we're adding 2 over 2 each time. Well, 2 over 2 is the same as adding 1. So our D really is 1, and we're working with arithmetic. So we got Sn equals n over 2 times a1 plus an. Well, they said we're going to do 8 terms for this one, so that's good. They give us the n. And these 3 questions are about as nice as you will ever get with arithmetic series, because they're going to give us everything. They tell us the a1, and we've got our last term there, the an as well. So all we have to do is fill everything in the calculator, and we would end up getting 32. Similar idea for all the others, because they said we're going to do the series out to 8 terms. So we'll just have 5 plus 61. So that'll give us 264 when we put it in the calculator. And lastly, same idea. S8 is equal to 8 over 2. 1765 is our A1. Now, for this last term, we can either do plus a negative, or plus a negative is really just a minus. You could put it in as just a minus if you wanted as well. When we put that in the calculator, these are sometimes the ones that I think are the most interesting, because we're going to be adding some positive things and some negative things. So when we punch it in, we get 4,292. So this means that overall, when we added it up, it had more positive value than it had negative value. So again, those are about as easy as they come. Probably on your test, I wouldn't give you one that easy. The ones that more like I would give you on the test are like these next ones. So evaluate each series. We know it's a series because we got the pluses between. We should always ask arithmetic or geometric. Well, in the first one, we're going up by 2 each time, so that's arithmetic. So we'd want to think our arithmetic series formula, which again, you'll have to memorize for the test. We want the 10th term, so we're doing S10 is equal to 10 over 2. Our first term happened to be 2. And then we got to go off to the side to find the AN, which would be the 10th term. So we'll go to our reference sheet. We'll get our arithmetic sequence formula, remembering to put the D in parentheses. So we got 2 plus 10 minus 1. Our D also happens to be 2 here because it was going up by 2 each time. We end up getting 20 back for that. And when we punch that all in, we end up getting 110. So if we added up the first 10 terms there in that series, we would get 110. All right, I'm not going to rewrite the formula for this one because we have it right above, but we'll have S100 is equal to 100 over 2. Our first term was 2, and we got to figure out what the 100th term is. Now this one we might be able to shortcut. You could use your sequence formula on the far right like we have there. If we started at 1 and did 100 terms, we would end at 100. So if you start at 2 and are just adding 1 each time, we should shift over 1 and we're just ending at 101. So this one you can kind of just think about and it makes it a little easier. And this would end as 5150. And our last one for today, this is going down by 0.04 each time. That's what tells us it's arithmetic. So we're going to have S12 is equal to 12 over 2 for the first term of 0.17. Let's go off to the side. We're going to use our arithmetic sequence formula to find the 12th term. First term is 0.17 plus 12 minus 1 times a negative 0.04. Remember, if you weren't able to pick out that negative 0.04, D, you always do the second minus the first. So 0.13 minus 0.17 would give us the minus 0.04. This will tell us our 12th term is minus 0.6. So again, you can either do plus a negative 0.6, or you can just do minus, because plus a negative is just a minus. And we end up getting negative 0.27. So that's the sum if we added up those first 12 terms. And that's it for today. If you have any questions on things, feel free to post them on the content discussion board.